Good day, class. For this session, we will talk about one of the most essential topics in algebra. But before we proceed, I want you to take a look at this picture. So what can you see in the picture? There is a man holding a guitar or playing the guitar for a our objectives of the day or target. We have differentiate polynomials from expression, classify polynomials according to the number of terms, and arrange polynomials in descending order. So first, what is polynomial? It is an algebraic expression involving only positive integral exponents for variables and no variable in the denominator and radicand. So it means that the exponents are positive only and there is no variable in the denominator and inside the radical symbol. The question is, are all algebraic expressions polynomials? The answer is no. Okay? Given the algebraic expressions, they may be polynomials if they have positive integral exponents and they don't have variables in the denominator and radicand. Okay? So determine whether the following is a polynomial or not. Explain why not. Number 1, x over 3. That is an algebraic expression that is polynomial. Okay, so number 1 is polynomial expression because the variable is on the numerator, not on the denominator. Then, the exponent of the variable is positive. That is positive 1. Okay? Number 2, negative 3 ABC. Okay, this is an example of polynomial because there is no variable in the denominator, there is no variable on the radicand, and there is no negative exponent. Okay, all the exponents of the variables are positive. That is positive 1. So a raised to 1, b raised to 1, and c raised to 1. Number 3, 4x cubed, y raised to negative 5. That's right. Number 3 is not polynomial because, as you can see, the variable y has negative exponent. Okay, that's why it is not polynomial. Next, number 4, a raised to 5 times the square root of 3. That's right. It is polynomial because the exponent of the variable a is positive 5 and as you can see, the radicand is not variable. Okay? So, number 4 is polynomial. Number 5, that's right. It is not polynomial because the variable a is the radicand. Okay? Or it is inside the radical symbol. Number 6, 14x raised to 2/3 times y. Okay? As you can see, the exponent of x is 2/3. It should be positive integral exponents or positive whole numbers. Okay, so 2/3 is a fraction, therefore, number 6 is not polynomial. Okay, so the exponent of the variable should be positive, then it should be whole number. Okay, number 7, 9 times a raised to 0.1 times b. As you can see, the exponent of a is 0.1. Okay? It is not whole number. It is decimal number. Therefore, number 7 is not polynomial. Number 8, the quantity of a minus 3 divided by 2. Therefore, number 8 is polynomial. Okay? Because the exponent of a, the variable a, is positive 1. Okay? Number 9, 3a raised to 25. Very good. Number 9 is polynomial because the exponent of a is 25. That is positive whole number. So number 10, we have the square root of 3x raised to the 5th power. In this case, there is variable inside the radical symbol. Therefore, number 10 is not polynomial. So, we can identify whether the given algebraic expression is polynomial or not by looking at the variable. Okay? So, if the exponent of the variable is positive whole number, automatic that is polynomial. And there should have no variable in the denominator and inside the radical symbol. So observe the following. A squared has one term. A squared minus 1 has two terms. A squared plus AB plus 1 has three terms. A squared plus AB minus B squared plus 1 has four terms. Now, how will you define terms? Very good. Terms are the parts of an algebraic expression separated by plus or minus signs. So we can count the number of terms because they are separated by plus or minus. As you can see, there is no plus or minus here, a squared. So we can count this as one term. Okay? In this case, there is minus. Okay? There is minus sign. Therefore, this is one term and this is one term. Therefore, it has two terms. Then we can count this as 1, 2, 3. So, 3 terms. Then 1, 2, 3, 4. 4 terms. Okay? So, we can count the number of terms because they are separated by plus or minus. So, determine how many terms are involved in the following. Number 1, 3x over 2. That's right. It has one term. Okay? Because there is no plus or minus sign. Therefore, we can count this as one term. Number 2, 12 times x plus 4y. As you can see, we have here plus sign, but you have to be careful since they are grouped. In this case, since they are inside the parentheses, we will consider the operation as this, multiplication, 12 times. So 12 times x plus 4y, this expression has one term only because there is multiplication, okay? We will consider multiplication as operation, not this plus, because they are inside the parentheses, okay? So number 2 has one term. Next, number 3. 3 plus b divided by 7 minus 5c. As you can see, this 3 plus b divided by 7 is considered as 1. Okay, is considered as 1 because of division. Then, because of this minus, we can say that this 5c is also one term. Therefore, we have one term, then another one term. Therefore, number 3 has two terms. Number 4. So, this c times x minus 2 is considered as one term. Then, let's count the number of terms. We have a, that is 1, plus b, that is 2, minus c times x minus 2, that is 3. Therefore, number 4 has 3 terms. Then number 5, 2a, that is 1 term, plus b, that is another 1 term, minus 2c, that is another 1 term, plus x times y divided by 2, that is another 1 term. So we have 1, 2, 3, and 4. So number 5 has 4 terms. So these are the classification of polynomials according to the number of terms. That's why you have to be careful on identifying the number of terms on the given polynomials. As you can see, 3a is a monomial, then 2b plus 1 is a binomial, then number 3, a plus 2b minus z is a trinomial, then 5a plus b minus 3c plus 9 is a multinomial or plain polynomial. Okay, what have you noticed? So for number 1, we have one term. Then it is called monomial. Then for number 2, there are two terms. It is called binomial. Number 3, there are three terms and it is called trinomial. For number 4, we have four terms and it is called multinomial or plain polynomial. So, to name the polynomials, when is a polynomial considered monomial, it has one term. Then binomial, it has two terms. Trinomial, it has three terms. Multinomial, it has four or more terms. Okay, mono means one, bi means two, tri means three, then multinomials, that is four or more. So determine the number of terms involved and name the following polynomials. Number 1, 2x squared plus 2y. Number 2, negative 9x yz. Number 3, a squared plus b cubed minus c plus 4. And number 4, the quantity of 3 plus x cubed divided by 6. Then number 5, a raised to the fifth power plus a to the fourth power times b to the fifth power minus a times b cubed minus b to the seventh power plus 3 to the fourth power. So, number 6, we have negative 15 b c plus 2d. Then number 7, a to the fourth power minus b to the fourth power plus c to the fourth power. Number 8, m plus n minus k. Then number 9, 3x cubed minus 3x squared minus 3 squared. For number 1, we have two terms, okay? Then it is called binomial. Number 2 has one term and it is called monomial. Number 3, we have four terms. Then it is called multinomial or plain polynomial. Number 4, we have one term and it is called monomial. Number 5, as you can see, we have 1, 2, 3, 4, and 5 terms and it is called multinomial or plain polynomial. Number 6, we have two terms and it is called binomial. Number 7, we have three terms and it is called trinomial. Number 8 has three terms. How? Because there is subtraction besides the parentheses. Okay, it means that we have 1, 2, 3 terms. Therefore, number 8 is trinomial. Number 9, we have three terms. Therefore, that is trinomial. Number 10 is not polynomial because the exponent of c is negative number and there is a variable or letter inside the radical symbol, which is b. Okay? So, what do like terms means? Suppose we have this example, 3x squared, x squared, and 4x squared. They are like terms. Then a squared times b squared, 3a squared times b squared, negative 12a squared times b squared. Then, unlike terms, we have 3x squared, x, and 4x cubed. Then, ab squared, 3a squared b, and negative 12a squared b squared. What have you noticed? So, like terms are monomials that have the same variables raised to the same exponent. Okay, as you can see on our example number 1, so take a look at the variable x. Then what is the exponent of x? That is 2. So x is squared. Then here, our variable is x, then the exponent is also 2. Here, our variable is x, then the exponent is also 2. Okay? You have to take a look at the variable, then its exponent. Then for number 2, our variable is a, then raised to 2. Then our variable is b raised to 2. Then here, the same, variable a, then raised to 2, and variable b is raised to 2. Here, we have variable a raised to 2 and b raised to 2. Okay? That's why they are like terms. Okay? On the other hand, if the variable are the same but not their exponents, therefore, they are unlike terms. Or simply, if they have different variables, therefore, they are unlike terms. So for our generalization, what is a polynomial? It is an algebraic expression with, first, no negative, fractional, and decimal exponent. Okay? So the exponent should be positive and whole number. Letter B, no variable in the denominator. Then letter C, no variable in the radicand or inside the radical symbol. Next, how will you define terms? Again, terms is a constant, a variable, a product or a quotient of constant and variable separated by plus or minus. Then, what are the classification of polynomials according to the number of terms? We have, first, monomial, if it has one term, binomial, if it has two terms, trinomial, if it has three terms, and polynomial or multinomial if it has four or more terms. So that's all for today. Thank you so much and God bless you all.